Today, we're taking a deep dive into exponents, roots, logarithms, that whole world. But don't worry, this isn't some dusty textbook lecture. We're going to see how these concepts pop up everywhere.
Oh, absolutely. From money to music, even to how we measure earthquakes.
Okay, so picture this. You've got a dollar, right? Basic. But then it doubles every single day.
So day one, $2. Day two, it's 4, then 8.
And it just keeps climbing. But here's the thing. You're not just adding 2 each time, are you? You're multiplying again and again, and that's where exponents will come in.
It's that repeated multiplication that's what we call exponential growth. And it's the reason things can escalate so quickly.
It's like that doubling game we saw in one of the articles, right?
Hmm.
But before we get too far ahead of ourselves, maybe we should clarify some of these terms. We keep saying base and exponent, but what do they actually mean in this context?
Think of it this way. The base is your starting point. It's the number you're multiplying by over and over again. So in your doubling game, the base would be 2, because each time you're doubling.
Okay, so the base is like our foundation. Got it. And then the exponent. What's that all about?
So the exponent, that tells you how many times you're hitting that multiplication button. It's like a shortcut, mathematically speaking. So 2 to the power of 3, which just means 2 times 2 times 2.
Which we know is 8.
Right. So instead of writing out all those multiplications, exponents give us a nice, tidy way to represent it.
But hold on. We've got these exponents making things bigger, but what about those square root symbols we see? Are those related to all of this?
Oh, they're definitely related. Think of it like the tree growing taller, branching out, but the root, that symbol that lets us dig down, see where it all began.
If we see something like the square root of 9, what we're really asking is what number multiplied by itself gets us to 9?
And in that case, the answer would be 3, because 3 times 3 equals 9. That radical symbol, which is just a fancy way of saying square root sign, it tells us we're going in reverse, looking for the root of that exponential growth.
So we've talked about exponents, we talked about roots. Now for the really mysterious one, logarithms. What are those all about?
Yeah, they do have a way of sounding a bit intimidating, don't they? But logarithms, really, they're just another way of looking at exponents.
One of the research papers we have called them the detectives of the exponent world, which I love.
So instead of asking, what's 2 times 2 times 2, with logarithms, we're saying 2 raised to what power gives us 8. It's about finding that missing exponent.
And we know, in that case, the answer would be 3.
Precisely. And this becomes incredibly useful when we start dealing with things on a huge scale. Think about the Richter scale for earthquakes. It uses logarithms to represent those massive amounts of energy.
Oh, right. And one of the articles called that the earthquake mystery, trying to get our heads around how much stronger one earthquake is compared to another.
And logarithms make those huge differences easier to grasp. It's the same idea behind measuring sound in decibels or even the pH scale in chemistry. It's a way to make sense of extremes.
So we've got these 3 concepts. We've got exponents pushing things forward. We've got roots taking us back to the source. And then we've got logarithms acting like detectives to uncover those hidden relationships. It's really amazing when you think about it. Our research mentioned a few interesting activities. Have you ever heard of the Exponent Olympics?
Yeah. It's this fun way to really solidify the concepts we've been talking about. You can imagine it like a relay race, right? But instead of passing a baton, each person has to solve an exponent problem to unlock the next stage of the race.
Such a cool idea. And then there's that root treasure hunt. That one sounded pretty creative, too.
And the treasure isn't gold or anything. It's these hidden roots scattered around, and you have to use your knowledge of roots to find them.
It just makes you realize that math can be so much more than just memorizing formulas, right?
Together, they paint this really complete picture of how math functions.
It can be this really tangible, interactive thing.
Yeah. Imagine being able to just easily calculate compound interest or really grasp how those population growth models work.
Right, or even scientific notation, another area where exponents come in super handy.
It lets us express these incredibly large or even really small numbers in this really concise way using exponents. Instead of writing out some massive number with 20 zeros after it, we can represent it much more efficiently using scientific notation.
It's a superpower for dealing with these vast, vast scales that we encounter in astronomy or even in the microscopic world of cells and molecules.
It helps us make sense of those numbers that would otherwise be, honestly, pretty unwieldy to even try to wrap our heads around. And there's always more to uncover, you know, it's this never-ending journey of discovery. And speaking of discoveries, remember that exponential spiral activity we touched upon earlier?
Oh, right, the one where you use a compass and a protractor to draw out a spiral where the distance between each loop, it doubles as you go.
Yeah, exactly. So each loop of that spiral represents the next power of 2, 2, 4, 8, 16, and it just keeps going. It's a visual representation of that doubling game we talked about. You can actually see that exponential growth happening right before your eyes.
You can literally see how much faster that curve grows compared to just a straight line, which would represent linear growth.
And it's that visual difference that really drives home the point of just how significant exponential growth can be. Because it's not always intuitive, which is why I think that activity is so effective.
It reminds me of that chessboard story that we started with. What seems like a totally simple request, just double the grains of rice on each square.
Yeah.
It spirals into this astronomical number, something that's hard to even imagine.
It highlights the power of that repeated multiplication and how it can lead to these truly remarkable and sometimes unexpected outcomes. The more we learn, the more we uncover these hidden depths to these concepts and how they shape everything. It really boils down to this. These concepts, they're not just about crunching numbers in a classroom. It's about understanding change, how things grow, how quickly they can decay, and how we make sense of it all.
It's like these hidden patterns are subtly visible everywhere you look.
Yes. And like a good detective story, sometimes the most interesting part isn't just finding the answer, but the new questions that pop up. And just because something grows exponentially, well, that doesn't automatically make it a good thing.
It really makes you stop and think, are we heading towards another one of those chessboard situations where things just escalate way beyond what anyone could have predicted?
It's a question worth asking for sure, but it does highlight how important it is to understand these concepts, right?
It's about paying attention, looking for those patterns, and like you said, not being afraid to ask questions.
Because the more we understand these mathematical concepts, the better equipped we are to, well, to navigate this complex world.
It's like we've been given this new lens to view things through, and suddenly things that seem totally unrelated, music, earthquakes, even those viral tweets we talked about, there's this common thread. It's pretty amazing.
And that sense of wonder, that curiosity, wanting to know the why behind the what, that's what real learning is all about, isn't it?
Until next time, everyone, happy calculating.